Hi, this is Richard C. I'm a math tutor here at Wyzant, answering questions submitted by a student. And it's a word problem, so I'm going to just start by drawing a diagram. So I have a triangle. We'll call it FGH. And we're told that angle G is 33 degrees. Little g, which is the side opposite the angle, is 20 inches. Little h, which is the side opposite the h, angle h, is 15. Okay, so because this is not necessarily a right triangle, we can't use any of the right triangle things like SOHCAHTOA or Pythagorean theorem. We have to use law of sines here. And the law of sines says the sine of 33 over 20 is equal to the sine of angle H over 15. So the sine of H is going to be 15 sine of 33 divided by 20. H itself is going to be the inverse sine of this. So I'll just put that into my calculator. Make sure I'm in degree mode because this angles were given in degrees. And I'm going to take the inverse sine of 15 times the sine of 33 divided by 20. And this gives me 21.1 degrees. Well, now we have to ask ourselves, is this the only possible answer for H? And for that, we need to think about the unit circle a little bit. So we have an angle here that's 21 here. But if I have another angle that's 21 over there, they're going to have the same sine. So the sine of this angle is the same as the sine of this angle here. And this angle, the other possible value for H would be 180 minus 21.1, which would be 155.9. So now we have to explore whether 155.9 is a possibility. If it were 155.9, then we'd have 33 for angle G, and then 155.9 for angle H, and that's going to be 188 degrees, 188.9 degrees. So 155.9 is not a possible solution. We can't have more than 180 degrees in a triangle. So this is our one and only solution. This is not a solution. Okay, so now that we know that this is 21, we can now take F, the measure of angle F, is going to be 180 minus 21 plus 33. So let's do that. 21 plus 33 gives me 126. So that's the angle of measured angle F. And now the last thing we want to find here is GH. We'll call it X. Once again, we can use the law of sines. So the sine of 33 over 20 is equal to the sine of 126 over X. And we solve that for X. X is going to be sine 126 times 20 all over sine of 33. So we do that on our trusty calculator here. And let's see, 20 times sine of 126. And then divide that by the sine of 33. And this gives me 29.7. And that seems reasonable. X is 126 is by far larger than these other sides. So you would expect this to be quite a bit larger. Actually, this seems a little small to me, come to think of it. But when you compare it against 20, it's 50% increase. So I guess it's not that unbelievable. But that's the answer we get. And so luckily there was only one solution. Had there been another solution, then we would have had to go back and find that as well. But now we know this is, so we solved the triangle. So we did this. We solved the triangle. And now the last step is to get the area. So the area is going to be 1/2 AB sine C. This is the formula we're using. And we might as well use this 126. So it's going to be 1/2 15 times 20 times the sine of 126. And so this is just more calculator work. And that gives me 121.35, and the units here would be square inches. So you can't use the 1/2 base times height. You know the base, but you don't know the height. Now, if you wanted to go down that path, you could. You would have to drop, just change colors. You would have to drop a height here. And then you could use, I think you could just use, you might be able to just use SOHCAHTOA, I'm not sure. Yeah, you'd be able to use SOHCAHTOA and figure this out. You'd be able to figure out how big the angles here are. And it would be, it's possible to do it, but it's lengthy. Far easier to use this formula here, which is a general purpose formula for the area of any kind of triangle, just as 1/2 base times height is. Okay, so that's it for this problem. I hope this solution was useful to you, and I'll see you again next time. Bye-bye.